Hi everyone, it's Kira Garfola with Math 109 at Greenville Tech again. Today we're going to discuss section 1.4, which is equations of lines. Just a refresher from our last section, we can write linear equations in the form of slope-intercept, which is y equals mx plus b. Remember that in this case, m is our slope and b gives us part of the coordinates for our y-intercept. It'll always be 0b at the intercept. Slope-intercept form is often most convenient, but there's several other ways to write equations for lines that we'll often see, or sometimes it's more convenient than slope-intercept form, especially if we're starting with points and not an equation. One of these forms is point-slope form. The equation of the line with a given slope that goes through a certain point can be found as y minus y1 equals m times the quantity of x minus x1. Now that looks like a lot of symbols, but don't get too worried. The y1 and the x1 will be substituted by those values in the point above. The m is the slope that we already know. So everything plugs in, and the only letters that are left in that equation are the original y and the original x. In some problems, you'll be given the slope, and in other problems, you'll need to find the slope first. We'll see some examples here in a minute. So let's first talk about the equation in point slope form of the line with a slope of -2 that goes through the point 1, -3. Here, we know that our slope is -2 because the problem told us that. So we'll see that m equals -2. We also know from the point that x1 is 1 and y1 is -3. So using point slope form, we'd get y minus -3, because that's y minus y1, equals -2, that's our slope, times x minus 1. Now you just use a little bit of algebra to simplify that to get y plus 3 equals -2 times x minus 1. Now, if we wanted to put this equation into slope-intercept form, all we need to do is rearrange. Remember that slope-intercept form, all we do is solve for y. So we need to isolate y here. Since there are parentheses, I'd like to distribute that -2 first. So we'd have y plus 3 equals -2x plus 2. And then we move the 3 to the other side. Voila, y equals -2x minus 1. Just to confirm, -2 is our slope, which is what we should have seen because that was given in the original problem. And our intercept for the y-axis would be 0, -1. Now, let's do a little bit more practice again. This is going to come in handy for your homework. We want to find the equation in any form of the line that goes through the point 1, 4 and the point 3, -2. So here our slope isn't given, which is fine. We can find the slope because we have two different lines. Remember that slope is rise over run, or y2 minus y1 over the quantity of x2 minus x1. So we can find the slope as 4 minus -2 divided by 1 minus 3. Looking at this, we get a slope of -3. Now we can use point slope form. I'll use the first point, 1, 4, because I just tend to always use the first one that's given. You would get the exact same answer if you found it using 3, -2. I would encourage you during this lecture to pause and try to work this out yourself. And then also, if you follow along here, at the end, pause and try it again with the other point. It's great practice. You will be asked questions like this on the test. So we have y minus y1, which gives us y minus 4, equals m, so -3, times x minus x1, which is -1. Or 1, excuse me, x minus x1 would give us x minus 1. So y minus 4 equals -3 times x minus 1. And that's it. So another practice problem is here. I highly encourage you to practice these on your own, but these are great to walk through to get an idea of what you need to do. So first, we want to find the equation in slope-intercept form of the line that goes through these 2 points. The first thing you're going to have to do if all you have is 2 points is find the slope. So finding the slope using the y2 minus y1 approach over x2 minus x1, we get a slope of -1. Then we can write it in point slope form. We don't have the intercept here, so going straight to slope intercept form will be difficult. But we can write it in point slope form as y minus 7 equals -1 times the quantity x minus 1. Then we're going to solve for y. Remember, if you have it in any form, point slope, just some random x and y all mixed up with an equal sign, solve for y and that will get you to slope intercept. Here it's fairly simple. We're going to distribute that -1 and then we're going to move the 7 to the other side so that y is alone. So we get y equals -x plus 8. It's always good to do a quick check. We don't know the intercept, so we'll have to take that one at its face value. But we also know from above that the slope was -1. Looking at slope intercept form, we see -x plus 8. So -1 is indeed our slope. It's always a good idea to double check those because it can catch your algebra mistakes. I myself make those mistakes on a very regular basis. We've mentioned some special cases before in other sections, but we're going to dive a little deeper into them here. Horizontal lines, remember, are constants. They always take the form y equals b. There is no x term. They stay the same no matter what that value of x. This is the same as slope-intercept form because remember the slope is 0. So it's 0x plus b. No problem there. We just know the slope is 0. So for example, if you're asked to find the equation of a horizontal line going through a certain point, all you need to do is y equals whatever the y coordinate is. It doesn't matter what x is. X could be anything on the whole number line from -infinity to +infinity. It stays the same y value no matter what x is. So here we have x equals 3 and y equals 5. Well, it doesn't matter what x is, but we know that y equals 5. So to write that equation, we will have y equals 5. Now, we can do the same thing with vertical lines, except vertical lines are always at the same x. It doesn't matter what y is, but the x is always the same. Remember, this isn't actually a function, it's just a line. It doesn't pass the vertical line test because it is itself a vertical line. So it always takes the form of x equals a because x is the constant here. So for example, if we want to write the equation for a vertical line passing through the point 1, 3, it doesn't matter what y is, but we know that x equals 1. So we will just write the equation x equals 1 for that vertical line. So there's some other types of specials, and parallel lines are one of those. Parallel lines have the same slope. So given any line, there are infinitely many other lines that are parallel to it. They could be on top of it, they could be to the left of it, they could be to the right of it, above it, below it, you name it. They have identical slope. They will never get closer, never get further away, never touch the original line. So if you know that a line has a slope m, then a line parallel to it will have identical slope, also m. So for example, if we need to find the slope of a line parallel to y equals 3x plus 2, we need to consider the slope. Our original line is already in slope-intercept form, so we know that m equals 3. So our slope for our original line is 3. Remember that the lines are parallel. They have the same slope. So any line parallel to that original line must also have a slope of 3. Those are the easy test questions, right? I give you a slope and I ask what the slope of a parallel line would be. It's the same slope. You've already found it. It's more of a definition question than a math question. So any line, you could name any line with a slope of 3 would be parallel. You could have y equals 3x plus 1,000,000, and it would be parallel. Y equals 3x plus 0 is parallel. Y equals 3x minus 500 is parallel. The important thing is that that slope is 3. Now, kind of the opposite of parallel is perpendicular lines. Remember from geometry, the perpendicular lines intersect at 90 degrees, so it's a right angle intersection. If a line has a slope of m, then any line perpendicular to it will have a slope of -1 over m. So it's the negative reciprocal. If you remember reciprocals and fractions, you flip the fraction over. So if you know that line 1 has a slope of m, then -1 over m is the slope of anything perpendicular to it. There is one exception, and that is horizontal lines, because we know that a horizontal line is perpendicular to a vertical line. But remember that a fraction is undefined if 0 is in its denominator. So -1 over 0 is undefined. So we can't actually write the slope for a perpendicular line to an original horizontal line. Just know that vertical and horizontal are perpendicular, but you do run into that 0 denominator undefined business if you're not careful. So for example, most of the time we're not going to have a horizontal constant function, so it's not a big deal. But for example, let's say that you want to find the slope of a line perpendicular to y equals 3x plus 2. It's the same example that we had before, but now we need to find a perpendicular line to it. Our original line, remember, has a slope equals to 3. So finding the opposite reciprocal, the reciprocal of 3 is 1 over 3, and the opposite would be -1 over 3. So any line perpendicular to this line must have a slope of -1/3. Now we're going to talk about something that has very close relationship with slope, and also is useful in calculus should you continue on to that course. For any given function, the average rate of change, not the range of change, that's a funny typo, I just now saw that. The average rate of change from x equals a to x equals b is found as the change in f of x, divided by the change in x, which is the f of b minus the f of a, all divided by b minus a. Look familiar? It's a lot of symbols, but you are literally just finding the slope between those 2 points. So look at the points on the function a and b and find the slope. That is the average rate of change. The cool thing about this is it's true for any function. Even if it's a crazy curvy function, it's true. You're going to plot the 2 points. If you draw a line between, straight line, just between those 2 points, ignoring the rest of the function, the slope of that straight line will give you the average rate of change. So graphically, we can look at this. We see that this point in the lower one, the red point, is at point A, comma f of a, which is really an x and a y, right? F of a is just the value of y at that given x of a. And we have b, f of b. So if we wanted to find the average rate of change between this point and this point, notice the actual function is going up, and it's going down, and it's going back up. We have a roller coaster of a function here. But really, our average rate of change is just that straight line slope. Doesn't matter what it does between, it's an average. We're kind of smoothing it over. So all we're going to do is find the slope between these 2 lines. So we do y2 minus y1 and divide by x2 minus x1 to get that slope. As I said before, this comes back to visit you in calculus. If you find yourself in that class, it actually is one of the fundamental underpinnings of a lot of what you'll do in Calc 1. Let's consider an example here. The velocity of a particle is given by the function v of t equals 9t squared plus 3, where t is the number of seconds since initiation. So you want to know the average rate of change of velocity between 1 and 3 seconds. So where t equals 1 and where t equals 3. So we know t equals 1 and t equals 3, but now we need to find their y values or their v of t values at those t values. So v of 1 plugging into the original is going to give us 12, and v of 3 plugging into the original is going to give us 84. So when t equals 1, y equals 12, and when t equals 3, y equals 84. Our average rate of change is just the slope between these points. So 84 minus 12 divided by 3 minus 1. That is going to give us 36. Make sure you can try this out and do this on your calculator on your own. Remember to use lots of parentheses if you're going to combine steps. This is certainly something you want to know how to do for the test. Now we're going to talk about something that a lot of people think looks ugly, and it is. It's not really complicated. It's basically exactly what we just did. But we're finding something called the difference quotient. So rather than saying at x equals a and x equals b for the average rate of change, now we're going to find it between a certain x point and then x plus some number. So x plus h. And h is just a placeholder here. Could be any number. The formula is f of x plus h minus f of x, and you're going to divide it by h. You can show that with algebra that you're just using that average rate of change formula. Because, let's see if we can go to the whiteboard. If you have, so we already know that we're doing f of x plus h is going to be our y2 minus f of x is our original y1. Then we need to divide it by x2, which is x plus h, minus x1, which is really just x. So the bottom just simplifies. This cancels with this. So that's why our bottom just simplifies to h when we're dealing with difference quotients. Now, going back to our slideshow, possibly. Technology is fantastic, huh? Okay, so we have a formula for what we need here. We're going to be given f of x, and h is just a letter, but you will need to plug x plus h into it. So you're going to assess that function at the value x plus h first. So let's find the difference quotient for f of x equals 12 minus 2x. So like I said, I always start by finding f of x plus h. This, in my opinion, is the hardest part. It's the easiest place to make mistakes. So let's find that before we even start plugging it in. We have f of x plus h equals 12 minus 2 times x plus h. Because remember, anywhere that you see x, you now have to replace with x plus h. So now you get 12 minus 2x minus 2h if you're just distributing this 2 here. So remember, 12 minus 2x minus 2h. So that's what we'll need to plug in for f of x plus h. Now it's just a matter of careful addition and subtraction. So we have f of x plus h minus f of x. And so on top, h just stays on the bottom. But we'll have f of x plus h, so 12 minus 2x minus 2h from up here, that's right here. And then minus f of x, so minus our original 12 minus 2x. The trickiest part here is to always distribute that negative. So now we have 12 minus 2x minus 2h minus 12 plus 2x. Notice here, 12 and minus 12 cancel out. Negative 2x and plus 2x cancel out. So all we're left with is negative 2h over h. Those h's cancel, and our difference quotient is simply negative 2. Just a sweet little word of advice here. Our difference quotient, if we have a linear function, big if, okay, our difference quotient is equal to the slope as long as it is a linear function. Here, our slope, we could rearrange this into mx plus b. We'd have negative 2x plus 12. Our slope is negative 2. and the difference quotient is -2. That only holds true for linear equations, as you'll see here in a second with a nonlinear. Okay, so let's do another example. Let's have f of x equals x squared plus 1. I'm going to open the whiteboard because I think that's going to be our easiest place to do this. So we know that f of x equals x squared plus 1. So that means that f of x plus h will equal x plus h, we just plug that in anywhere we see x, squared plus 1. Now we can FOIL this out because that's not very helpful right now. So using FOIL or using the rules, since we're squaring it, we know that this comes out to be x squared plus 2xh plus h squared. And then we still have that plus 1 from the original. I apologize that my pluses look like perpendicular symbols. My stylus is not cooperating. Okay, so now our expression is going to be f of x plus h minus f of x all over h. So that is going to equal what we just found, x squared plus 2xh plus h squared plus 1 minus x squared plus 1 all over h. Now we need to distribute this negative, okay? So we get x squared plus 2xh plus h squared plus 1 minus x squared minus 1 all over h. Now, a lot of these should start falling apart and canceling. If they don't, go back and check your math. So here we see a positive x squared and a negative x squared. Those cancel. There's nothing with an 8 over here, so that won't cancel. But we see a plus 1 and we see a minus 1. So all we're left with is 2xh plus h squared over h. Now that h on the bottom is going to cancel because there's an h in each of those. So that is going to come to be just 2x plus h. That is our final answer as our difference. Yes, I realize that that looks daunting, but really take it one step at a time. If you take it just one step at a time, it's really no more complicated than anything you're already used to doing. You know the formula, and just as a side tidbit, if you're asked on the test to find the difference quotient, I will give you that formula. I will give you, let me see if I can change it. I will give you this formula here, okay? I'm not going to ask you to memorize that. There's no reason for you to memorize that. Okay, so that is actually all that we have for section 2.4. I look forward to seeing you. We're done, or 1.4, not 2.4. On the next one, we'll start with chapter 2, and we'll continue on with our functions. Remember that if you have any questions, our Blackboard page is full of extra resources for you, and that you can always reach out to the Math Center or to me by email or stopping by during my office hours. Thanks, and I hope that you guys have a great and fantastic day.